Here's something almost every human being alive agrees on without a second thought. Gone is gone. You had breakfast this morning, and now that breakfast is over. It played out, unfolded, and then ceased to be. Your first day of school, the summer you were 12, the conversation you had with your grandmother before she died. These things happened, yes, nobody disputes that. But they happened the way a fire happens. It burns, it gives off light and heat and reality, and then it goes out. And once it's out, it's out. The flame doesn't persist somewhere. The warmth doesn't linger in some other dimension. It's just gone. The universe, as most people understand it, has one moment that exists. This one. Right here, the thin knife-edge boundary between what has already happened and what hasn't happened yet. Everything to the left of that edge has evaporated. Everything to the right hasn't arrived. Only the sliver of now is real, only now, and then a new now, and then another. You feel this in a very physical way when you look at old photographs. There's a version of you standing in someone's backyard at a birthday party, age 7, holding a piece of cake. That kid existed. That kid felt the weight of that plate, smelled the frosting, heard the noise of that specific afternoon. And now it's as though the universe took all of that and fed it through a shredder. Not just the person, but the moment itself. The light that bounced off those backyard leaves, the particular quality of that afternoon air, all of it processed and discarded to make room for this moment. The universe, if you ask most people, is in the business of creating the present and demolishing everything else. Stop 100 strangers on the street. Ask them, is the past still real? 99 of them would look at you like you'd lost your mind. Of course it isn't. What a bizarre question. The past is over by definition. That's what past means. The 100th person, maybe she works in a physics department. Maybe she teaches relativity. And she would give you a completely different answer. Because there is an entire framework of physics, not fringe physics, not controversial speculation, but the same physics that lets your GPS pinpoint your location to within a few feet, that gives you the precise timing systems that modern civilization runs on, that points quietly and insistently to a conclusion almost nobody has heard, or if they've heard it, almost nobody has taken it seriously enough. The past is not gone. It still exists, not in a poetic sense, not as a metaphor for memory, legacy, or meaning, physically, geometrically, in the same way that the city of Tokyo exists right now, even though you're not in it, even though you might never go there, even though you're nowhere near it and have no way of getting there tonight. Tokyo is still there. The past is still there. The equations tell us so. And these are not new, exotic, unverified equations. They are over a century old, confirmed by tens of thousands of experiments, and they are the foundation on which the modern technological world is built. To understand why, we have to take a short trip into physics, and I promise it won't hurt, because this story actually starts with something very simple. Imagine you and I are standing in a field together. I snap my fingers. A sound goes out. We both hear it. We both agree. That snap happened at a particular place at a particular time. If there are 20 people standing in that same field, they'll all file the same report. Yes, he snapped. It was at that moment. No dispute. This is what time looks like when nothing is moving very fast relative to anything else. It behaves. It cooperates. Clocks tick together. Moments are shared. Everybody agrees on the sequence of events, on what happened before what, on what was simultaneous. The trouble begins when things start moving. Not the kind of moving we're used to, not car speeds or airplane speeds. speeds that approach the speed of light, and it starts with a question that a young man in Switzerland couldn't shake loose from his mind. That young man was Albert Einstein. He was 26 years old in 1905, not a professor, not a celebrated theorist. He was employed as a patent examiner in Bern. He spent his days reviewing technical drawings of mechanical devices and his spare mental energy on a question that had been bothering him for nearly a decade. What would it look like, he wondered, to travel alongside a beam of light, to keep pace with it, to ride next to a wave of electromagnetic radiation as it moved through space? The answer he arrived at is one of the unstabilizing ideas in the history of human thought, and it leads, step by step, with the inevitability of a logical proof, to the conclusion that the past has not disappeared. Here's the key discovery. The speed of light in a vacuum, roughly 186,000 miles per second, is the same for every single observer in the universe, regardless of how fast they're moving or in what direction. Read that again, because the words are simple, but the content is not. If I'm standing still and I clock a beam of light passing me, I get 186,000 miles per second. If you're hurtling to that same beam at 90% of the speed of light, you'd naturally expect to measure it as moving much faster relative to you. The same way a ball thrown at you while you're running toward it seems to hit harder, arrives with greater relative speed. But that's not what happens. You measure exactly the same speed I did, 186,000 miles per second, not faster by even a single inch per second. Every experiment designed to detect any deviation from this point has failed. Nature doesn't budge on this point. The speed of light is a kind of universal constant that doesn't negotiate with anyone's velocity. And this one fact, this single, stubborn, experimentally verified fact, is enough to unravel the simple picture of time completely. Here's why. Put two people in relative motion, one standing on a train platform, one riding a very fast train. A flash of light goes off at the exact center of one of the train's carriages. The light spreads out in both directions, forward toward the front of the carriage, backward toward the rear. From inside the train, the passenger sees a perfectly symmetrical situation. She's at rest relative to the carriage. Both flashes travel the same distance to reach the front and back walls. They arrive at both ends simultaneously. She files her report. Both walls were hit at the same time. Now look at it from the platform. The observer, standing on the platform, watches the train moving forward at tremendous speed. The rear wall of the carriage is rushing toward the rearward flash. The front wall is racing away from the forward flash. The speed of light, and this is crucial, doesn't change. Light is not like a ball you throw. The speed of the source doesn't add to the speed of the light. So from the platform, the rearward flash has a shorter distance to travel because the wall is coming to meet it. The forward flash has a longer journey because the wall is running away. The rearward wall gets hit first, then the forward wall. From the platform, these are not simultaneous events. From the train, they are. And here's where people want to object. They want to say, one of them must be wrong. One of them made an error. The train passenger or the platform observer, one of them has the right answer and one has the wrong answer. But Einstein's theory says no, neither is wrong. Neither has made a measurement error. Both descriptions are physically correct. The universe simply does not have a single global now that applies everywhere at once. Simultaneity, the question of whether two distant events happen at the same moment, is not a fixed fact about the universe. It depends on who's asking and how fast they're moving. This is called the relativity of simultaneity. Physicists have known it for over 100 years. It has been confirmed with atomic clocks on airplanes, with particle accelerators, with precision measurements of every kind. It is not a quirk in the math. It is real. And when you follow it to its logical conclusion, you end up somewhere very strange. Here's a thought experiment that was first articulated in a version similar to this by the physicist David Deutsch, building on ideas from Einstein and others. It's come to be associated with something called the Andromeda paradox. Picture two people on a sidewalk, walking slowly in opposite directions. One is drifting casually in the general direction of the Andromeda galaxy. Her body is aimed that way, more or less. The other is ambling in the opposite direction. They cross paths. For a moment, they are in essentially the same place. They could look each other in the eye. By any local human scale standard, they share the same moment. But here they differ. They are moving in slightly different directions and at slightly different speeds. Their velocities are different, which means their planes of simultaneity, physicists' term for what they each call right now throughout the rest of the universe, are tilted at different angles through spacetime. Andromeda is about 2.5 million light-years away, and that distance is so vast that even a tiny difference in velocity, just a few miles per hour between two people walking, causes their slices of right now on Andromeda to differ by days, weeks potentially. For one of the walkers, a particular decision is being made on Andromeda right now, say a civilization deciding whether to send an expedition toward our galaxy. It's happening at this very moment. For the other walker, that decision is in the past. It was already made. Days ago, in her frame, it already happened. Both of them are standing on the same patch of sidewalk. Neither is mistaken. The laws of physics assign equal validity to both their perspectives. Now here's the wall you run into. If the same event can be in the past for one observer and in the future for another, and both are equally correct, you cannot maintain the position that the past doesn't exist. You can't say the past is gone and also say the event is in the past for this person while it hasn't happened yet for that person. Something that hasn't happened yet must by definition exist somewhere in the structure of reality, and something that's in the past must still be there to be pointed at. The only picture of the universe that makes consistent sense of this is one in which all moments, past, present, and future, exist simultaneously as a single, unified, four-dimensional structure. In 1908, a mathematician named Hermann Minkowski, who had once been Einstein's professor at the Zurich Polytechnic, stood up in front of an audience and made a declaration that sounds, at first, almost mystical, but is actually a straightforward mathematical statement about the geometry of the universe. He said, "Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality." He was saying this: space and time are not two separate things. They are woven together into a single four-dimensional fabric. What we experience as three-dimensional space moving through time is actually the four-dimensional entity called space-time. And this entity doesn't move, it doesn't flow, it doesn't unfold moment by moment. It simply exists, completely, all at once. Every event that has ever occurred and every event that ever will occur already has a fixed address in this four-dimensional structure. Your first memory, the moment your parents met, the extinction of the dinosaurs, the formation of the sun, the death of the last star, billions of years in what we'd call the future. All of it is there. All of it has coordinates in space-time. None of it is more real than any other part. This is the block universe. Physicists also call it eternalism, and it is not a minority or heterodox position. It is what you get when you take the equations of special relativity seriously and don't stop halfway. Think of it this way. Imagine you have a book.
The entire text of a novel bound between two covers. Every page exists right now. When you're reading Chapter 3, Chapter 22 doesn't disappear. It's still there, waiting in the binding. The story doesn't exist only on the page you're currently looking at. The entire story exists simultaneously. You're just moving through it. The block, according to the block universe view, is something like that book, except instead of pages, the slices are moments in time. Instead of chapters, there are eons, and the reading, the experience of moving through it, of feeling time flow, of living inside a present moment that seems to be the only real one, that's just the way conscious beings navigate their path through the four-dimensional structure. What physicists call your world line is your path through spacetime, all the moments of your existence laid out as a single continuous thread from birth to death, all of it already there in the geometry of the universe. The block doesn't care that you feel like you're moving through time. The block just sits there, complete, containing all of it.
Now, I can hear an objection forming. Two objections, actually. The first is the free will problem. If the future already exists in the block, if the moment of your death is already sitting there in space-time, already as real as right now, then doesn't that mean everything is predetermined, that your choices are already decided? This is a genuinely hard question, and I won't pretend otherwise. But I'd say this. The block universe doesn't necessarily mean your choices are irrelevant or illusory. It means your choices are part of the structure. Whatever you choose, freely and for your own reasons, that choosing is woven into the fabric. You experience the deliberation, the weighing of options, the genuine uncertainty of what comes next. That experience is real. Whether it constitutes free will in the philosophical sense people argue about is a debate that was running long before Einstein and will run long after. The physics doesn't settle it. It just adds a new dimension to it. The second objection is more technical. Maybe this is just one interpretation. Maybe there is another way to read the equations that doesn't require the block universe. And it's true that a position called presentism, the view that only the present moment is real, still has defenders in the philosophy of physics. But presentism has an enormous problem. It cannot be made consistent with special relativity without adding extra assumptions, hidden preferred reference frames, invisible structures we've never detected that have no evidence for them at all. Presentism requires the universe to have machinery we've never found any sign of. The block universe, by contrast, requires nothing extra. It is not an interpretation imposed on the math. It falls out of the math on its own, like water running downhill. You take special relativity seriously, you follow it where it goes, and you arrive here. Einstein himself seems to have understood this and accepted it. When his lifelong friend Michele Besso died in the spring of 1955, just weeks before Einstein himself would die, Einstein wrote a letter to the Besso family, and in it he said something that has always struck me as one of the most quietly radical sentences any scientist has ever written. He said that the boundary between past, present, and future is nothing more than a stubborn and persistent illusion. He wasn't consoling them with poetry. He was telling them what the physics concludes. So let's come back to where we started and see how far we've come. We began with the most obvious, common sense, universally agreed upon belief that exists. The past is over, gone, erased. Only now is real. Then we found that the speed of light is the same for every observer, regardless of how fast they move. That single fact forces us to accept that simultaneity is not universal, that two observers in different states of motion will have different but equally valid accounts of which events are happening right now across vast distances of space. Once simultaneity is relative, now is no longer a global fact. It's personal, dependent on your state of motion. One person's present is another person's past. One person's future is already in someone else's history. And once you accept that, which you must because the experiments demand it, you can no longer say the past doesn't exist. The only coherent picture left standing is one where all of time exists, simultaneously, as a four-dimensional structure, a block, complete, whole, unchanged. Your childhood isn't gone. It's located in a different part of spacetime. The afternoon of your 7th birthday still exists, the way Paris exists, just somewhere you can't currently get to. The Roman Forum still exists. The moment of the first heartbeat of the first human being still exists. The last afternoon of your life already exists. Not any of it is more real than right now. We just have access to our particular path through the structure. I know this sounds like something you might want to argue with. I know the presentist intuition is deep. It's written into every language, every lived experience, every grief you've ever felt over the loss of a moment. And there are physicists who are not fully satisfied with the block universe picture, who think there's something missing, some mechanism of becoming that the equations aren't capturing. But I'll say what I think is true, and what I think the history of physics teaches. Whenever the mathematics of a well-tested theory pointed to a reality that felt impossible, atoms, curved space, quantum superposition, the math was not wrong. It was telling us something. The universe is strange. Our intuitions evolved for a very specific set of circumstances, slow speeds, human scales, everyday life. They did not evolve to navigate the deep geometry of spacetime. When the geometry contradicts the gut feeling, the geometry has earned more trust. The equations are telling us nothing is lost. Everything that has ever been is still there in the four-dimensional structure of the universe, as real as the ground under your feet. I want to leave you with one image. When you remember a moment from your past, something that mattered, something that hurt, something that made you feel completely alive, you experience the memory as a kind of echo, a trace left behind. The real thing is gone, you tell yourself. This faint signal in your nervous system is all that's left of it. But if the block universe is correct, the memory isn't an echo of something that ceased to exist. The memory is a compass needle pointing at something that is still there. That moment still occupies its location in the structure of spacetime, as vivid and complete and real as it was when you were in it. You're just further along your world line now. You're somewhere else in the block, but the moment is not gone. Whether that thought makes you feel lighter or heavier probably depends on which moments you're thinking of. But here's the question I'll leave you with, because I think it cuts to the center of all of this. If the physics is right, if the past is not gone, if it still exists, if every moment that has ever been is still there in the geometry of the universe, which moment from your life changes the most, knowing that it didn't disappear? Think about it.